All right, so let's go ahead and wrap up this problem. It's a doozy. All right, lots going on. So where we left off is we know that the cosine of 3 theta is plus or minus 2 square roots of 7. So again, let me rewrite this cosine of beta. All right, and let's just go ahead and look at 2 square roots of 7. The plus minus just means we have reference angles in all 4 quadrants. So if I find one, I pretty much find them all. So our beta, right, would be the arc cosine of 2 over the square root of 7. So let's go figure out what this beta is. So I'll go to my calculator. We are in degree mode, so I'll stay in degree mode, and we're talking about the inverse cosine of 2. Let me bring on my fraction. Right, 2 all over the square root of 7. So the calculator is giving me, it looks like 40, 89, 34. So this looks like it's 40 degrees, right, 89, 34. So that's basically that guy. Now remember, if we drew a picture, right, that's our angle in quadrant number 1. But because we're expecting the things in all the quadrant, that means that this is here and here and here. So to find, so we already know that one of our betas, if you would, is this guy. So to find the one in quad number 2, right, we basically take 180 minus that. To find the one in quad 3, we take 180 and add that. And to find the one in quadrant 4, we take 360 and we subtract it. So that's our strategy for each one. So following that strategy, this one, right, so we have 180 minus the 40.8934, and that gives us 139.1066. And then the next one, we're just going to add that. So let me come over here and change that to an addition. And that's 220.8934. And then the next one, we're taking 360 and subtracting it, which gives us 319.1066. Okay, so that's what we basically have at the moment. And so let me go ahead, right? So what we have, let me cut away to a new need some more room here. So for what our work is, right, our 3 theta in just the first revolution is 40.8934, 139.1066, 220.8934, and 319.1066. All right, and since the period has now been shortened, right, our new period is 2 pi over 3. That's just the first revolution. So now what we have to do is go to the second rev and actually the third rev to get that. And so here we're basically going to add 360 to all these values, and here we're going to add 360 to those values to basically get everything that we need. And so some of these are easy. If I add 360 to this, we're going to get 400.8934. If I add 360 to that, right, we're going to get 0.1066, but it looks like we get a 499, I believe, right? Yeah. Okay. If we add to the next one, we're going to get a 0.8934, and then adding 360, we get 580. And then to the next one, we're going to get 679.1066. So there's the second rev. And then to do the third rev, I'm going to add 360 to all these. All right, and this is getting a little mundane, but hopefully you guys get the idea. But here's what we get: we get 700.8934. If we add 499 to this, let's see, 9 and 6 is 15. Carry the 1, we get 8. Let me make sure I did that right. 15, yeah, so 859.1066. If we add it to here, 0, 4, carry the 1, we end up with 940.8934. And then if we did it one more time, 1066 point, let's see, we get a 9, 7 and 6 is 16, carry the 1, 1060. Whew. All right, so those are all the third revolutions. And now the really fun begins, and I'm going to go ahead and stop here, right? Because now what I do, right, to solve for theta, to get theta by itself, right, I eventually have to divide all of these by 3. Okay, and I'll do the last one just so you can see, right, if I did that last one, right, we got to stay within 360. So 1069.1060, was it 1066? If I divide that by 3, what we get is 356. So this last one is 356.36, looks like 89. So clearly we can see that the last one we have here falls within the 360. The rest is just a ton of number crunching, right? I'll even do the first one. So the first one, right, if we do that, oops, is 40.89, oops, 34. So that first one is 13.6311. So 13.6311 degrees. So there's the first one, there's the last one, and then you got all the divisions by 3 in the middle. So it's just basically at this time a huge calculator effort. I think the most important thing that we did is the trig part, right? So we solved for the cosine, we invoked our square root property, right? We invoked our calculator to get the value since that wasn't a nice ratio, and then we used our reference angle ideas to find all the corresponding angles in each quadrant in the first rev, right? And then since we were tripling the angle, I got to go 3 revolutions out, and we basically just take advantage of our coterminality to get all the rest. And it's just a huge number crunching things to go from there to get, I got the first one, got the second one. You just keep doing those divisions to get everything in between. And it looks like we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's actually 12 solutions in the first revolution for this equation right there. So pretty complicated, but again, it brings technology to the board, brings our reference angles to the board, and then just all our number crunching, which I'll leave to you guys at that. I'll make sure I cover the trig and let you guys do the number crunching on your own. All right, so there you have it. So hopefully you've kind of seen everything all together. I do want to cut away to the secant tangent one that I messed up with, and I'll finish off with that one where we also will use some technology, as you'll see in a moment. But see you guys then.